Hello, my name is Lindy Humphrey, and this is my second lab report for Physics 2211. To introduce this lab, the purpose of this lab experiment was to observe the motion of an object falling from rest straight down. The motion measured will then be compared in computational models that will show how the different known forces affected the object's position and compare these predicted motions to the motion observed in Tracker. Some big ideas or fundamental principles we have to keep in mind for this experiment is Newton's second law, also known as the momentum principle, which states that acceleration on an object is equal to the net force on the object divided by the mass of an object, and for this experiment it is important to note that Newton's second law is not equal to 0. This can be written as F final equals F initial plus F net over m times delta t. We must also note that an object falling has non-constant velocity, meaning F net will also not equal 0. A few other forces we must keep in mind for this experiment is the force of gravity, or the weight force, and drag force, also known as air resistance. A brief overview of the results of this experiment is that the graph with gravitational force and drag force will be more accurate than the graph with just the gravitational force. To further understand the fundamental principles that will be affecting our object in this lab, let's describe some of those forces and its impact on the motion. The force of gravity is the force between any two objects with mass, and the acceleration due to this force of gravity on Earth is 9.8 meters per second squared. To calculate this, we multiply the gravitational constant 9.8 meters per second squared by the object's mass. Drag force or air resistance is a force opposite to any object in motion, and it impacts our object's velocity on the way down from a fall. The system in this experiment is our object falling, which in my case is a stuffed turtle, and the surroundings impacting this turtle include air resistance that may affect its position going down, and the earth pulling down on the turtle. Here is the video of me dropping the turtle. I made my axis as the point of where I first dropped it, and that way its starting position was at 0, and its resting value was also 0. And as it drops, you can see the diamond shapes tracking its motion down and the corresponding data on the side of this observed motion. Using GlowScript, I first needed to get my data points for an object falling with only gravity acting on it. I set my initial position and velocity vectors to 0 as it was my starting at rest in the origin, and changed my delta t to the time frame of my video. I also changed the total time for the length of my object falling and filled in any of the formulas to calculate F net. After it ran, this was the predicted position of an object falling with just gravity acting on it. Then I needed to find the position of an object falling with gravity and drag acting on it. In order to do so, I slightly changed the GlowScript code as seen here, and this is the graph it gave me to show position over time. Then I combined the data points from Tracker for the observed position, the data GlowScript gave me for just gravity acting on the object, and the data I got from drag and gravity acting on the object to compare the data. As we can see, the predicted data of gravity and drag acting on the object is a lot closer to the observed motion and is more accurate to what would happen in the real world, since more factors act on an object, such as air resistance. However, there could have been some errors in the data as they are not perfectly aligned, and this could have been from other forces acting on the object that I did not take into account for, such as friction, or some other error using the object that I did, for example. The first question we have to answer is, what does it mean? And it asks if any of the models predicted a terminal velocity. And the graph considering the gravity and drag will predict the terminal velocity because terminal velocity occurs when a drag force is considered. And from the graph, we can see that the velocity ultimately is going to a constant. This will also mean that the net force will be 0, as drag force and gravitational force will equal out to 0. The last one was, imagine if the object was initially thrown downward, would the terminal velocity in this case be the same or different if it was initially dropped from rest? And only the initial velocity would change, as it would start moving at a faster rate initially. However, the terminal velocity would be the same and not have changed, as it is only affected by the weight of an object or the drag force and the gravitational force. Thank you.